give a warm round of applause for Ariel.
Thank you. I'm really excited to be back at CodeConf. I guess I'm representing the veterans here, so yay, geeky. Speaking of geeky, how many of you are familiar with this image here? A few of you, okay. Some real geeks here. No offense. I always like to start my talks with this image because this is an image taken from one of my favorite spacecrafts, Voyager 1. And if you can see that tiny little pale blue speck of a pixel there, that's Earth as seen from about 4 billion miles away. So that's where you can find me if you need me. Also in San Francisco, though. And why I love this image so much is because it shows us how space exploration often changes our view of ourselves and our place in the universe. But similarly, I think we should change how we view space exploration. And that's what a lot of my work focuses on. I work on hacking space exploration, essentially. But it should really be called hacking space observation, because that's really the relationship that most of us have with space exploration. We're often observing astronauts and government agencies exploring on behalf of us, but we ourselves aren't doing much exploring. And so this actually relates to my own personal story, because I actually don't have a background in science whatsoever. I went to art school and I worked at an ad agency for a number of years. But back in 2008, I was watching this great documentary called When We Left Earth. And it was this really great documentary. If you haven't seen it, I totally recommend it. It's this documentary about NASA trying to figure out how to send people into space in the early days and how they were trying to figure it out. And I became so incredibly inspired by this documentary that I decided to send someone at NASA an email saying that I was a huge fan of what they were doing, and if they ever needed someone like me, someone completely without a science background, that I was around. I didn't expect to hear back from it. It was sort of like a geeky fangirl moment, so to speak. But serendipitously, I was able to get a job at NASA from that email, and it completely changed my life. And so I just wanted to share a quick clip from this documentary that might sort of explain why I found it so inspiring. See if we can get the sound going on it.
Must launch a man into Earth orbit. Only rockets can go fast enough.
We knew nothing about rocketry, we knew nothing about spacecraft, we knew nothing about orbits.
Big kick out of watching the Mercury astronauts. It was great looking at their eyes.
We're looking at this thing and looking at each other and deciding we want to go back and talk to the engineers a little more before we go further.
That was what I love so much about this documentary. It actually reminds me of this image here. That NASA in the early days, they didn't yet know space exploration. They didn't know what they were doing. They were figuring it out as they went along. And so I was watching this at home going like, well, I don't know anything about space exploration. I want to work at NASA. That sounds amazing. And so I got that chance, and it was completely life-changing. And it really changed my view of NASA from being a bunch of rocket scientists to being a bunch of space hackers, that they were figuring out space exploration as they went along. And so working at NASA was really great. It was like getting paid to go to school. I got to learn about dark matter and robots and all these different things. But one of the most important things I ended up learning while I was at NASA was that I didn't even need to work at NASA in order to explore space. And so I left. And I created spacehack.org, which is a directory of ways to participate in space exploration. So these are things you can do with or without a formal science background to actively participate in space exploration. So things like building rovers or discovering galaxies. One project that I really love on SpaceHack is the Austrian Space Forum, which is essentially an organization that's trying to build up a ton of Mars research for anyone who might one day go to Mars. They don't say who necessarily will be going to Mars, whether it's SpaceX, NASA, India, China, whoever. What they're trying to do is build up enough research about like spacesuits and how we might discover life and what sorts of international space laws we might run into, so that anyone who does end up going to Mars will have a bunch of research backing them. And so what you can actually see in this image here is you can see someone actually digging through an ice cave in Austria in order to try and find signs of life similar to how we might try and find it on Mars. The thing that's cool about the Austrian Space Forum is that they look for volunteers from all different disciplines and all different backgrounds to sort of help their mission and help get people ready to go to Mars one day. There's also cool projects on SpaceHack like Galaxy Zoo Radio, where you can actually discover black holes, classify and potentially even discover new black holes that no one's discovered before, which is pretty awesome. And then more recently, a project that I created with a friend from the SETI Institute, which is the Search for Extraterrestrial Intelligence Institute. My friend Lisa Ballard and I got together and we created a site called Space Probes. The URL is spaceprob.es. And this site essentially shows and catalogs all the human-made machines that freckle our solar system. So all of the active space probes that are out there in our solar system at the moon and beyond, this site catalogs it. And what we actually did for this is we scrape the XML from NASA's Deep Space Network, which is the actual satellite network, or rather antenna network, that works to communicate with all these space probes out in the solar system. So we scrape the XML from that, I think every 10 minutes or so, and then we have our code up on GitHub if you're interested. I think our username is Space Hackers, if you want to check it out. But it's quite a fun project. So you can see all the distances change, and you can actually see where all these space probes are at any given time. Other cool space hacks that I've come across is one that was called What Color Does the Internet Think Pluto Is? And why I love this hack is because it shows that you don't have to necessarily be using data from NASA in order to do cool space hacks. You can also just create your own data. In this case, someone actually did a bunch of Google image searches, and they were able to actually extract the illuminated pixels that depict the color that people depict Pluto as in blog posts. So a lot of people have depicted Pluto as being blue or purple. In actuality, it's much closer to a reddish hue. And so someone wanted to actually ask sort of what color does the internet think Pluto is, and why is that? So they used Python, they extracted all the illuminated pixels, and then were able to create this grid. And you can sort of see there's like a pretty half and half distribution between the warmer hues and the cooler hues, which is pretty interesting. Also interesting because the New Horizons spacecraft, which is the spacecraft that's going to Pluto right now, is about 18 days away from reaching Pluto. So we're going to have, for the very first time, close-up images of Pluto, and hopefully the internet will start weighing in that it's more of a reddish hue than a bluish hue, but I guess we can figure that out as time goes on. Another cool hack that I've come across is a group of people who wanted to essentially 3D scan supernovas. Supernovas are awesome, they're beautiful, we get these lovely images of them like this, but we don't really get a sense of them in space, so to speak. And so we can't exactly take a Kinect and hold it up to the sky and hope to get a 3D scan of a supernova that way. And we can't exactly shrink a supernova down and put it through an MRI machine and get a scan of it that way. But that's sort of what a group of people who were hacking around with stuff at Harvard did, is they actually took the open source tool 3D Slicer, which is usually used to take a bunch of MRI scans of a brain and then put it through a 3D sort of fly-through map. So they took this, this open source tool 3D Slicer, and instead of feeding it these brain scans, which it usually sees, they fed it supernova data and supernova images. So they actually fed it the Cassiopeia A supernova remnant, and they were able to create this. So this is actually the very first 3D fly-through of a supernova remnant that had ever been created. And this was because the medicine department teamed up with the astronomy department, and they were together able to actually produce this 3D scan of a supernova, which is really, really cool. So I really like multidisciplinary collaborations, and one of my absolutely favorite programs at NASA, although I'm incredibly biased because I'm on their external council, is the NASA Innovative Advanced Concepts program, also known as NIAC. And what NIAC does is they essentially fund all the more science fiction, futuristic, out there yet credible research that could actually transform future space missions. And they allow anyone to actually pitch them on these sort of things that people can research or prototype. So some of the things to come out of NIAC have been things like the Comet Hitchhiker, which when I first heard about it, being a bit of a space geek snob, I guess, I was like, well, why do we need a Comet Hitchhiker? We've already got a space probe that's at a comet called Rosetta, and it's super awesome. Why do we need another? Not that I would ever complain about having 2 space probes at a comet, but I didn't know how this was necessarily futuristic. So what the Comet Hitchhiker actually does is it's not just a concept for a space probe to go and land on a comet, it's actually a concept for a space probe to use the comet as a propulsion system to explore the solar system twice as fast. So the concept with the Comet Hitchhiker is to actually have a space probe go to a comet, harpoon into it, reel out a huge, incredibly long tether, and then harvest the kinetic energy from the comet in order to explore the solar system twice as fast. So with the Comet Hitchhiker concept, instead of it taking nearly 10 years to reach Pluto, which our current space probe, New Horizons, is, a space probe with the Comet Hitchhiker system would take more like 5.5 years. So it's, I don't know. And I just love like this idea of using like natural things like asteroids and comets as propulsion. There's also really cool projects like the Titan submarine, which is literally a concept to send a submarine to Titan, which is the moon of Saturn, and have it explore the lakes of methane and ethane there. And then this is a really cool one that essentially uses computer science and computer vision and a bunch of great algorithms. What you're looking at here is the moon and the sun as it goes across the moon on any given day. And what you're actually witnessing here is like this little rover trying as hard as it can to only stay in sunlight at all times. So it's sort of like a video game where, you know, the rover is going like, okay, the dark bits are lava, like don't touch them. And so what this project actually does is it is able to calculate a route in which a rover can always stay in sunlight. Why this is important is because rovers, a lot of times that are sent up, only work off of solar energy. And so if they can continuously stay in sunlight, they can keep working, keep doing science. They don't have to go to sleep overnight. So this was a pretty interesting project that's able to be done now because now we have even better maps of the moon than we even used to. So as I mentioned, NIAC is open for anyone to propose to. The first proposals, I think, are usually due around October or so, and they, just to start, they only ask for like a 3-page white paper. So you can actually submit a 3-page white paper on what your concept is, how you would prototype it, how you would research it, and anyone can apply and get funding. So what I love so much about space exploration and science fiction and all these things is how it's really about exploring the unknown. And sort of born out of this love of exploring the unknown came an event that I work on called Science Hack Day. And Science Hack Day is a 48-hour event in which scientists, designers, developers, and people from all different backgrounds and all different disciplines get together in the same physical space to see what they can rapidly prototype with science. So the mission of Science Hack Day is just to get excited and make things with science. They can be silly things, they can be serious things. It doesn't matter. It's just about making, you know, things with science. So I lead the organization for the San Francisco event, which actually last year and this year is taking place at GitHub headquarters. This is a photo from last year. If you are located in the Bay Area, the next one is in late October, so keep an eye out for that. And Science Hack Day is an event where it's grassroots and it's open and no one owns it. It's not an organization, it's not a franchise. You don't need permission to organize one. Anyone can organize one. And so I had the pleasure of visiting a bunch of Science Hack Days last year all over the world. I traveled to Medellin in Colombia. I went to Shanghai in China and to Antananarivo in Madagascar. And all of these events were amazing. So a quote that I love, that I think sort of defines, in a sense, Science Hack Day to me, is this quote from John Peel, that at the heart of anything good, there should be a kernel of something undefinable. And if you can define it or claim to be able to define it, then in a sense, you've missed the point. And so some of the undefinable things that have come out of Science Hack Day have been things like this. This is essentially a typeface someone wanted to create in which all of the letters would have equal wind drag. I don't know why they just did. So what you're actually looking at is a makeshift wind tunnel, and someone actually recorded the wind drag of each individual letter and then weighted each individual letter so that all the letters would have equal wind drag. So if you're wanting a typeface in which all the letters have equal wind drag, it looks something like this. Again, I don't know why, but this was a physicist who was playing with typography, which is something that I love. Other hacks to come out of Science Hack Day have been ones like this one. This is a prototype of a lamp that would light up every time an asteroid passed by the Earth. So it was sort of like a near-death lamp. You could you could put it on your desk and freak out your coworkers with it. So asteroids and near-Earth objects pass by the Earth actually fairly frequently, so this is actually quite a fun lamp to have. One to come out more recently was a hack called the Satellite Symphony. And this is a hack where you can go in and you can type in any location around the Earth, and you can see all the satellites that are currently overhead. But Satellite Symphony doesn't just show you all the satellites that are currently overhead, but it also puts them to music based on how fast they're going and how far away they are. And so why I love this so much is because when you're at school or you're at work or at home, you get a sense of how congested the traffic is outside. You get a sense of how busy it is or how quiet it is outside, but you never really have that sense for all the stuff that's overhead. So what Satellite Symphony does is it gives you sort of more of an ambient awareness of how crowded or not it is over your head at any given point. One to come out of this was from San Francisco last year at GitHub. Actually, I think it won Best in Show. It was an interactive planetarium. Essentially, they had created a planetarium in which instead of just lying back and observing all the stars over you, you could actually explore the stars and the planets and galaxies through using your hands and actually get information about any given planet or star and get more of a physical sense of the distances between these things. And so this was a really fun hack, and actually it went on to be an exhibit at the American Museum of Natural History in New York. We even had an astronaut play with it, which you can't get any better than that. In my book, it was pretty cool, and it's just a really fun hack. But my all-time favorite hack from a Science Hack Day was the Beard Detector, essentially a device that would detect when someone needed to shave. Which was a silly hack. Essentially, this guy wanted to detect when he needed to shave, and so he took a USB microscope, like the one you can see here, and he held it up to his face and got this really gross image of all the stubble on his face. I hope you all enjoyed lunch. And he wrote some basic code and used an open computer vision library, and the result was this. As you can see, it says, no beard found, and then it's drawing lines around his stubble and telling him when he needs to shave. Now, when I saw this hack demoed, I thought it was rather amusing, but I wasn't quite sure what it had to do with science. But we leave Science Hack Day open for interpretation, and it's kind of openly chaotic by design. But sitting in the audience and seeing this hack demoed was a particle physicist. And when the particle physicist saw this hack demoed, he said to himself, wow, that's actually a genius way for how to detect cosmic rays in a cloud chamber. Which sounds ridiculous until you see what cosmic rays in a cloud chamber looks like. And so following Science Hack Day, this particle physicist wrote an entire proposal and created a multi-year research endeavor about how to detect cosmic rays in a cloud chamber using the original code that someone had used to detect if they needed to shave or not. And this is what I love so much about hacking space exploration and hacking science. It's really about creating sparks for future ideas and future collaborations. And I just showed you a bunch of really awesome hacks, but I've been in Nashville only a little bit of time, but already I get a sense that there's a lot of awesome geeks here. And I think it might be time for a Science Hack Day in Nashville. So if you all could help me create that, that would be awesome. And you should try and get GitHub to sponsor you too. So with that, essentially when it comes to space exploration, there's a lot of things that you could be searching for. You could be searching for extraterrestrials, or you could be searching for exoplanets. But to me, it's really the search for experimentation that's so incredibly precious, and I think we've found it through hacking science and hacking space exploration. Thank you.